everyone, welcome back to Learn DSA with Sakshi Day 2. In previous video, we gave a brief introduction about what this series contained and we saw a basic intro of the DSA. In today's video, we are going to learn one of the most important and fundamental concept in data structure, that is the linked list. We'll start by understanding what a linked list actually is, how it is different from arrays, and then we'll move on writing some basic code in C++ using linked lists. So don't worry if you are a complete beginner. This video is designed to be super simple and easy to follow. By the end of this session, you will be confident with the basics and all set to move forward into more advanced topics like insertion, deletion, and traversals of the linked list. So grab your notebook, stay focused, and let's get started. So what is linked list? Linked list is a linear data structure like the arrays. Why it is linear? As I earlier said, we can access the elements of the linked list in a specific manner. So it is a linear data structure. And why it is different from arrays and why we need the linked list. As we know that we can store the elements of array in a continuous memory, but this is not the case in linked list. We cannot access the elements, or rather we can say we cannot store its elements next to each other in the memory. So it is non-continuous memory. Let's understand. In linked list, the data gets stored in the individual elements, which is called a node. Yes, a node is an element, and the node contains the data and the pointer to the next node. So basically, node is consist of the two parts. Therefore, connecting the each nodes forms a linked list. Now, let's understand linked list by taking the real life example. A linked list is like a chain of people holding hands together. Each person represents a node, and each node stores data and a reference to the next person in the line. So everyone knows who's come next, right? Now, talking about the differences between the linked list and arrays. Uh, in arrays, all the elements are stored next to each other in memory, like seats in a row. That sounds organized, right? But it comes with the limitations also. If you want to add something in the middle, you have to shift everything to make space. Similarly, deleting an element from the middle also needs shifting all the elements, right? So that shifting takes times, especially if the array is very big. But in a linked list, we don't need to move data around. So here we come with the linked list. We just change the links, we break one link and create a new one. So insertion and deletion in a linked list is much faster and more flexible than the arrays. Also, in arrays, you need to define the size beforehand or relocate memory if it's get full. But linked list grows as needed means you can keep editing new nodes and it will keep growing until your system runs out of memory. So if you don't know the size in advance or you want to do a lot of insertion and deletion, then linked list is the best choice. Now moving forward, here I listed the difference between the linked list versus arrays. So as you know that arrays are continuous and linked list is non-continuous as discussed. Then Arrays are of the fixed size, means you need to define at the time of creating it, whereas linked list is dynamics, it can grow or shrink as per the requirement. Then insertion in arrays takes time, whereas it is fast is in the linked list. Same for the deletion. Then memory usage is less in array, and linked list takes extra memory for storing the pointers. Then access time. Uh, Access time is fast for arrays because we can directly access the elements by using the indexes, whereas it is in slow because we need to travel from the start. If you want to get the last element of the linked list, then we need to travel the whole linked list. So that's why it is slow than the array. Then ease of use, it is simple for the small or static data, whereas linked list is the best for large data set or where we need dynamic allocations. So here is the difference for both of linked list and arrays. So here are the types of linked list. There are four main types of linked list. First one is the singly linear linked list, then singly circular linked list. Third is the doubly linear linked list, and last is the doubly circular linked list. So these are the four types of the linked list. Now we will see its visual representation from which you will get the clear idea. So firstly, I'll draw the diagram of each linked list and then I'll explain. So here are the diagrams of all types of linked list. So first is the singly linear linked list where you can travel only in the forward direction and the last node points to the null. Then in singly circular linked list, you can travel only in forward but it forms a circle and the last node points to the first node and the last node is not null like the singly linear linked list. Then here for the doubly linear linked list, you can travel in both the forward and backward direction where the first node's previous is null and the last node's next is null. And in doubly circular linked list, you can also travel in both the forward and backward direction and it forms a circle as you see. And the first node's previous points to the last and the last next points to the first. So these are the representation of all types of linked list. Let's move to other slide. So yes, now functions for the linked list means what we can do with the linked list. So here are the three main functions of the linked list and from that we can derive more functions. So first one is the insertion, then deletion, then traversal. Insertion means you can insert an element in where between the linked list where you want. Similarly, you can delete the elements from the nodes which you want. And then traversal means we can travel the whole linked list for the purpose of display and count, things like this. Then the insertion and the deletion function, it modifies the linked list. Means we can insert an element at specific position. Let's say like insert at first, insert at end, insert at the position. Similarly for the deletions. And traversal are the function which don't modifies the linked list, where you can just travel linked list for the sake of printing and counting the elements. So, so that's about the linked list. Types of linked list, what is linked list, difference between linked list and arrays, functions for linked list. Linked list is like a trail in real life. Each bogie is connected to the next, and if you want add a bogie in between, you just adjust the connectors, right? That's exactly how the linked list insertion and deletion works. So we will see it later. So that's all for today. In the next video, I will be covering deletion and searching operations in the linked list. And if you found this video helpful, don't forget to like, comment, and subscribe. See you in the next video. Thank you.